Hello, algebra students. We are going to be reviewing some Unit 6 content this evening. We are going to go through the different forms of quadratic equations, how to write the equation of a graph, and how to find the x-intercepts, the y-intercept, and the vertex of a quadratic. Okay, let's start by writing the equation of a graph. When we have a graph, we have multiple options for writing the equation. We can write it in factored form. Oh, it's terrible handwriting. Let's delete that and start over. Okay, so factored form. We also have vertex form. And we have standard form. Let's see, what color do I want to do? We'll do black. Okay, our factored form, we're going to take and find our x-intercepts and look at what those points are. So this one is between -2 and -4. So that is -3, 0. And this one is at -1, 0. So our factored form, y equals our two parentheses where we have our x's and we work backwards. So x minus what? Or -3 minus what gets us to 0? And that's +3. So we're going to take the opposite here. If you remember, we had, if I take that x plus 3, we find our x-intercept by setting each of these parentheses equal to 0. So I subtract 3 from both sides, and we get x equals -3. Now I can go backwards and say, all right, I want that 0 back. So what can I do? I can add that 3 back to both sides, and we get that x plus 3 equals 0. And that's our first set of parentheses. Okay, the second set of parentheses, we're going to do the same thing with that -1. So instead of having x minus 1, I'm going to have the opposite, x plus 1. And so that's my equation in factored form. The other thing I want to check is because our graph is opening up, okay, we're going up, we want to make sure this in front is positive. If my graph were to open down, like so, then we would need a negative number in front. So you just want to be aware of that, okay? Vertex form is going to be a little bit different because we are going to take that y equals x plus or minus a number squared and then plus our k value, our hk. So we identify our vertex, which is our maximum or minimum point. So here, this is our minimum, and it is the ordered pair -2, -1. So our h, again, the opposite of the x coordinate. So instead of having x minus 2, we're going to do x plus 2. And then our k value is as is. So instead of this plus, I'm going to put minus 1. That is the same equation in vertex form. Standard form, what we would do is multiply this together to break it down, or to write it in that x squared term plus an x term plus a constant. So we can do that using the box. We can also verify that our y-intercept is going to be the constant when we put this together. Notice that we are at 0, 3, so I know that I need a plus 3 at the end. So if we are using the box method to multiply this together, you are going to end up with x squared plus 4x plus 3. If you don't know what I mean by the box method, we will review that further down in this review. Okay. Now for the test, you only need one of these three forms. And from your graph, it will be this or this factored or vertex form that will be your most effective, efficient method. Okay? Now let's review how we find those x-intercepts. I talked a little bit about that in the problem above. It's when we are going to take the two parts. So I have negative 16t minus 2, and I have t minus 5. We are going to set those two parts equal to 0. So negative 16t minus 2 equals 0, and t minus 5 equals 0. And what we are going to do is solve each of these for that t value, because our x-intercepts are going to be those two ordered pairs. It's just what goes here in the blank. So I'm going to start solving this by adding 2 to both sides, because my goal is to isolate the t, and we're going to undo any addition or subtraction first. Remember, we work that order of operations backwards. Then I'm going to divide by negative 16, and 2 divided by negative 16 is negative 1/8. You might also write that as negative 0.125. So negative 0.125, comma 0. This one, same thing, t minus 5, we are going to add 5 to both sides, and we get t equals 5. Those are my two x-intercepts for 2a. Let me erase some of this so we can do part B. I ran out of space. All right. Same process though. Take that x. We've got this part and this part. So x equals 0. No solving needed there. We're already done. X minus 5 equals 0. Again, add 5 to both sides, and we get 0, 0, and 5, 0 are our two x-intercepts. For part C, same thing. We've got x plus 3 and x minus 3. So x plus 3 equals 0. X minus 3 equals 0. Add 3 to both sides. Subtract 3 from both sides, and we get x equals negative 3 and x equals positive 3. So we have 3, 0 and negative 3, 0 as our two x-intercepts. Okay, that's where we cross the x-axis, our horizontal axis. Now let's see where we cross our vertical axis, and that's finding the y-intercept. Remember, to find the y-intercept, we are looking for where x equals 0 already. So our ordered pair is going to be 0, comma, a number. And we're going to do that for both of these. So f of 0 equals 0 squared plus 2 times 0 minus 4. And when we do that calculation, we end up with negative 4. So our y-intercept is negative 4. Now you might notice a pattern. That negative 4 is the constant at the end. That is something to very much be aware of. We're going to do the same thing for part B. Put in 0 for x. And we end up with negative 3 squared plus 6. Negative 3 in parentheses, then squared. Negative 3 times negative 3 is positive 9 plus 6 is 15. So 0, 15 is the y-intercept. Number 4, using the distributive property. This is what I was referring to earlier as our box method. Okay, some of you may have seen how to do these problems using the box. This one, we really only need one row because we have an x, so let me erase the extra here. Okay. Helps if I look ahead at the problem. So we're going to take this outside. I like to put the left part on the left, and then our x minus 8 I'm going to put across the top. And then we just multiply. It's all about multiplying in. It's an area model. X times x is x squared. X times negative 8 is negative 8x. Some of you may have seen this before where we draw our arrows in. So we're taking this x into both parts of our parentheses. Okay, either way, we get an equivalent form of this equation as f of x equals x squared minus 8x. We can do the same thing on this one. Here, we do have a binomial times a binomial. So I'm going to do my x minus 3 and my x plus 2. You can bring the sign with if you want. I like to do that. X times x is x squared. X times 2 is 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. Now, when we are looking at this, you might notice we have some like terms here in our corner boxes. So I do need to combine those. So our new equivalent expression or equivalent equation is g of x equals x squared and then negative 3x plus 2x is going to give us negative 1x or negative x. It's the same thing there. And then minus 6. That's our equivalent equation. Our last one, we are going to take this x plus 2 squared, and that means I have two sets of this. So I'm going to put the first set here, x plus 2, and then the second set across the top. Fill this in. X times x is x squared. X times 2 is 2x. 2 times x is 2x, and 2 times 2 is 4. Now again, we've got these matching corners, 2x and 2x. So I am going to combine those, and we get h of x equals x squared plus 4x plus 4. We can also modify a vertex form equation. For example, this one here, my vertex form always takes that structure y equals a number, positive or negative, times x minus h squared plus k. Remember, if a is positive, we're going to open up, and if a is negative, we're going to open down. Okay, so again, a greater than 0, our parabola will look like this. A less than 0, our parabola will look like this. So if I want to take this equation and shift it 3 units to the right, that means my h value is going to go to the right 3 spots, and my k value 2 units up. So k is going to go up 2. How does that shift here? So my vertex is at the opposite x plus 1. What is the opposite of that plus 1? Remember, we're asking what makes this parentheses 0? Well, negative 1 plus 1 is 0. And then our k value is as is. So we're going to keep that 3. 3 units to the right means I'm going to add 3 to that negative 1. So my new h value is going to be negative 1 plus 3 or positive 2. My new k value is going to be that 3 plus 2 because we're going up, or 5. So then my new function, f of x, equals x, this is positive 2, so minus 2, squared plus 5. So we look at those changes. How do I need to change the h value and the k value so it fits the new situation? Let's take a look at part B. Part B, we have g of x equals x squared. Our vertex is going to be 2, negative 3. So again, that's our hk. And our parabola needs to open downward. What does that mean about my a value? Okay, so the changes we're going to make to g of x, we're going to change what's in front. We're going to change our h value, and we're going to change our k value. Well, I shouldn't put a plus there because it could be minus. All right, so my vertex is at positive 2. So my h is positive 2, so x minus 2. There we go, x minus 2. And then my k value is negative 3. Now my graph needs to open down, so that means this number in front has to be negative or less than 0. I can make it negative 1. It could be negative 2. Doesn't matter. But we do need to ensure that our parabola is opening down. Continuing on, find the x-intercepts, the y-intercept, and the vertex from all 3 quadratic forms. Now, it might be challenging to find all 3 from each of the forms, but let's focus in on what we can find from each of these. If you remember from our conversation above, in standard form, we're going to be able to find our y-intercept really easily because that's going to be our constant. In factored form, we're going to easily be able to find our x-intercepts because that's what makes our parentheses 0. And lastly, in vertex form, we're going to be able to find the vertex, and that's down here. Remember, our vertex, we take our h and k values to identify the vertex. Now, we can find additional information from each form if we take the time to make a table, okay, and maybe even sketch a graph. You will have those tools available to you using your TI-30XS calculator or just doing some good old paper and pencil math, making that table of values. So here we know our y-intercept right away is at 0, 5. Okay? So if I graph this, I know that 0, 5 is going to be on my graph. In my factored form, here, I know that my x-intercepts will be whatever makes my parentheses 0. So x plus 3 equals 0, and x minus 3 equals 0. We did solve those up above to get negative 3 and positive 3. Okay? And lastly, our vertex form. Our vertex at HK is what makes this 0. Well, we have x minus 1, so positive 1, and then my constant, negative 4, is my vertex. Now this one will be a little bit easier to find your x-intercepts because our vertex is always in the middle. So if I were to take the time to make a table of values, I might do 0, negative 1, and then 2, 3, and find those values to see if I can figure out where the y is 0. Okay? But we don't need to do that at the moment. X-intercept here, if you remember, to find our vertex, remember my h value is always going to be halfway in between our two numbers. So halfway between negative 3 and 3 is 0. You can remember that on a number line. So here's negative 3, here's positive 3. We have 6 spaces between them, so let's cut that in half. Okay, they're both going to come over here. Halfway in between is 0. Okay? And I can use that then to calculate the x coordinate or the y coordinate of the vertex, my k value. 0 plus 3 times 0 minus 3 gets me negative 9. And that happens to also be my y-intercept because the x value is 0. So that's my y-intercept in addition to. So our factored form helps us get all three in a somewhat okay fashion. Standard form gives us that y-intercept right away, and vertex form gives us our vertex right away. And then we could push to find our x-intercepts.